All right, first off, thanks everybody for joining my session. I'm Eric Internicola. This is ARKit and CoreLocation, and we're going to be talking about building compelling immersive experiences with it. So first, a little bit about me. This is actually from Saturday. I took a hike with my son nearby. So I'm an iOS developer full-time since about 2015. I was a hobbyist before that. Prior to that, I did full stack development. So I've done a lot of like back-end and front-end web stuff. I've been into map data for quite a long time. Pretty early in my career, I was into that stuff. So I'm a big map data geek. And I live here in Colorado, so I'm into backcountry skiing, rock climbing, mountain biking, hiking, and skateboarding, but that's not really relevant in this context. I work for a company called Adventure Projects. So my hobbies also happen to be my work. We're part of REI. I don't know if everybody's familiar with them, but they're a big outdoor retailer. And I am the iOS developer for 6 apps that we have: Mountain Project, Mountain Bike Project, Hiking Project, Trail Run Project, Powder Project, and then that co-op icon over there is the National Parks app. And they serve as digital guidebooks, so if you want to go hiking or mountain biking or rock climbing, we're all about how to get you there and make sure you know where you're going. My experiences, a lot of map-related stuff, but not always professionally. Location data, so as we'll see in a minute, I actually have a library where I deal quite a bit with location data and visualizing it. ARKit, I haven't released anything professionally yet, but I've been toying with it for quite a while. And SceneKit, I actually have a game in that, and that is highly relevant in this context. And then, of course, being here in Colorado, just going outside and playing. Early in my career, map-related stuff. I don't know if anybody's familiar with WMS, WFS, but basically it's a way of serving tiles from a back end if you're doing mapping data. So I have this library called GeoTrackKit, and the idea is collecting location data and then collecting statistics about that data, like if you're a skier, how many ski runs have you done? How many vertical feet have you ascended? That sort of stuff. And then visualizing that on a map, of course. So, little story time. So in 2017, I don't know if you remember Natasha the robots this week in Swift, but there was this really interesting and random cool stuff about ARKit and CoreLocation. I saw that in the newsletter and I was like, yes, I'm definitely clicking on that. And then there's these demos. So I go to the GitHub site and I see this first experience. That looks pretty cool. And then I see this second experience and I'm like, yes, that is what I want to do. That is awesome. So I clone the repo, and I give it a try, fire it up, and I see Canary Wharf, and that's about it. That second demo, there's nowhere to be found. I dig through the code, it's not in the repo. So we'll move on. What is ARCL? So it's a library, and as the original author Andrew put it, ARKit uses camera and motion data to map out the local world as you move around, and I'm sure you're all familiar with that. A lot of you are definitely familiar with CoreLocation, so using Wi-Fi and GPS data to determine your global location with a low degree of accuracy. I know we often think of it as high, but it actually is kind of low. And then ARKit and CoreLocation, we're combining the high accuracy of AR with the scale of GPS data. This is Andrew Hart. He's the original author. He lives in the UK. He's not really actively involved in the project anymore. However, he has this company called Dent Reality, and he recently put together a demo. I'm not sure if you've seen this before. He's moved on to taking these sorts of experiences for location, AR location experiences for navigation, and taking it indoors. And the idea here is you're navigating inside this mall to a store called O2. No idea what the store is, but as you watch, you'll notice that you're just following this pathway, and you get these arrows that show you exactly where to go until you arrive at O2. It took Andrew quite a few tries to get a clear pathway without people to build that experience. So that's what he's doing these days. So we'll talk a little bit about the library. So there's this concept of annotation nodes. And what I'm referring to is this sort of an experience where you're placing like a banner and depicting like Canary Wharf, that sort of stuff. And so these locations are not necessarily close to you. You can think of it like a billboard, and that was that first demo again that we're watching. And the API is called Location Annotation Node. Contextually, that'll be important because there's other types of nodes for different experiences. So we're just going to go through a quick code sample. So first, you create an image. And so we're just loading an image asset. In this case, it's a happy face. And the next piece is you need a world location. So this is a lat long, and then you need an elevation. And we'll talk a little bit later about why that's important. You combine the two, and you can do this all in one step if you extend CL location. And then you go and you tie these things together. So we take the image, and we take the location, and we create this location annotation node. And so we bind them together in this, and this is the API I was just talking about. And then finally, we go and we add this to our scene location view, which is an ARCL scene. And this is just a quick demo that I whipped up. And so the idea here is that we have a location for 4 different states. And so it's relative to my house. So we're looking at like New York. And so as you move around, you can see where the states are, basically what direction. Not the most compelling experience, but it demonstrates kind of what you can do. You can build some pretty incredible experiences with this. However, you can also place 3D node objects. So that was kind of like SpriteKit, if you're familiar with SpriteKit, and now we're moving more towards like SceneKit. So you can think 3D objects, and those first 2 demos that we saw really didn't do a good job of demonstrating that. The navigation kind of is loosely 3D objects, but not in the way that we're going to see. So we're talking about the LocationNode API. So what I'm doing here first is I'm specializing LocationNode. And in this case, I'm doing it more as a marker flag. It's not really functionally doing anything. It's just, as you'll see further in the example, to demonstrate specifically what type of location node we're going to be working with. So all it really does is gives us a factory creation method to go and build from a location. And so the idea is you pass a location that also has elevation, so it's latitude, longitude, and elevation. And the contract is it's going to hand you an arrow node back. So we're going to go and create an instance of this node with the location. And in this case, we're going to fail if we can't load it. It's a do not pass go, do not collect $200 scenario. And then what we're going to do is take this arrow node and add it as a child. This is a pretty common approach. And then in this case, we have some application-specific business logic. And the reason being, in this implementation, you can actually tap on the node to select it, and it will change the color to show that it's selected. And then we're going to go and return it, like any good factory creation method would do. And it creates you an arrow and returns it back. So that's essentially an individual arrow. Now, in the demo we're going to be putting together, though, we're going to move on from building one custom node to building a number of them. So in this case, we're going to take a trail. So if you can imagine an array of points that signify a trail, and I'm sure you can imagine my motivation behind this would be the apps that I work on a daily basis. So first, we make sure we have a track and make sure that we have more than 0 points. That's important. And then we're going to go and create a container, just an array where we're going to put these location nodes and hold on to them. And then what we're going to do is iterate over all of these track points, and essentially we're going to go and translate them into these 3D objects that we will then render. So first, for convenience, we grab a reference to the current point just to work with, and then we're creating a placeholder, a let for this node. And then what we're going to do is go and take a look at the index and figure out what we're creating from there. Now, we didn't actually look at endpoint location node, but the idea is that we want to create a different type of node, a non-arrow, to signify the start and end of the track. And it's going to look something like this. It's a collection of torus, or a tori for the plural. So we're going to do that for both the starting point and the ending point, and the difference is just the color. And so again, the endpoint, collection of torus. And then what we're going to do for every other point that's not either end of the array is we're going to create an arrow. And so again, the arrow. It's a fine looking arrow. And then what we're going to do is we're going to add those nodes into the array, and then finally return the array of nodes. So if you remember in the first block of code, we were creating one arrow, and now what we've done is we've taken a whole array of points and converted them into a collection of objects. So these are scene kit objects that have a real world position, latitude, longitude, and elevation. Okay, so we've gotten through that part. We've built a whole bunch of location node objects that are specialized. So let's add them to the scene now. So we want to visualize them. So we've got this function called add track points. Now this is pretty important. In the application, so we're taking a scene and we're working in the context of the real world. So the scene has a current location, but it's optional because for those of you that have worked with CoreLocation, you have to say, hey, I want a real world location, give me a location callback to tell me my location, and you have to wait. So you wait for that callback. So the first thing we do is we check to see, do we have a real world location? The next thing we check is the accuracy okay-ish? And this is in meters. So we're saying, do we have a real world location that has an accuracy of at least 15 meters of error? Ideally, we want better than that. And if we don't, then we just dispatch. Half a second later, we'll try again, and we return. So next, we're going to just delegate off to that last function that we created. If you remember, it creates all of these scene kit objects that are then inserted inside of these location node objects. And then we're going to iterate over each one of those, and we're going to call this add location node with confirmed location. Very verbose, but it conveys that we're giving a location node, and it has a real world location. So we're adding this to our AR scene, or more specifically our ARCL scene. And then we're just keeping a reference to them because we're going to work with them in other points of the application. So we've just got a reference for shorthand. And then we're actually going to go and take each one of these arrows and make it point to the location of the next arrow, because initially they're all just going to be pointing up, which is less useful. Having an array of arrows pointing upwards for every geo point, not great. Having them point where you want to go, that's what we're looking for. And in this case, what I'm looking to do is find the arrow that I'm closest to right now. And the idea being, if I'm out on a trail and I'm halfway and I say, oh yeah, I've got this cool AR experience. So I pull it out and I'm looking for the closest point to me. All right, so here's a demo video. So this is Powder Project, one of the apps I work on, and I've been prototyping with this. So I took this out to St. Mary's Glacier. Another side note is that I'm big into skiing. I ski every month of the year. So far I have 106 consecutive months of skiing. So I'm pretty committed. So I took this out last month to St. Mary's Glacier with the AR experience, and I figured I'd kill two birds with one stone. Now this video is sped up, so it's a little jarring, pretty rocky terrain. But what we're looking at is these are the arrows, and what they're doing is pointing to each other. And what's really neat is if you saw there, the trail split into two directions, and those arrows very clearly show me the direction that I want to go. And here I'm hiking up a muddy glacier, and I'm just following these up. And as an aside, you'll notice there's not a lot of detail to the arrows. It's because I didn't do anything with lighting. There's a really nice feature in SceneKit where you can say use default lighting. I highly recommend you either set up lights, or use default lighting, and you'll get more detail. And at this point, I'm skiing down. And for those of you that are familiar with the color spectrum for skiing, green is easy, blue is intermediate. And so here I go, skiing down. Again, very jarring footage. But as I get close to these, I've sort of arbitrarily picked 7 meters. When I get within 7 meters of an arrow, it removes itself or hides it, and then it shows the next 5 arrows. So as you can see, that one just disappeared. And we're moving on. Not a groomer, not at all. It was like skiing on maybe an ocean wave that's been frozen. Okay, directions. So going back to that demo that was missing, a pull request came in a while back that sat around for a while. And a point that I didn't mention is that I am a contributor and also, so I've done some work on this project. I'm a maintainer and contributor on ARCL. Pull request came in, and I immediately started looking at it and had to bring it up to date. But yeah, we have an ARCL navigation experience at this point. So we're going to go take a look at how you achieve this in code. Now in reality, it's not a lot of work. So we're actually going to look a little bit at doing direction requests first. So sort of the tooling that would get you to the point where you're ready to do navigation. So first, we're going to set up a directions request. So the idea is that we create this MK directions request, and these are Apple APIs, it's part of MapKit. And we're going to say we want to start at the current location, and we're going to go to a destination, for example, Boulder, which is what I put in that demo. And I'm going to say don't request any alternate routes, and the reason being I'm just picking the first one. It's a very primitive demo. There's no like, here's 3 routes to choose from, so it's very basic. And then it's an asynchronous call, so you call directions.calculate with that request, and you get a callback. So the first thing we do is we check, do we have an error? If we do, we just essentially swallow and print out to debug the error, and we make sure that we've got at least one route. Or I should say that the routes are not nil. Then we delegate off back to the main thread, and we say, add this route to the scene location view. And again, the scene location view is this ARCL scene. So it's literally one line of code once you actually have your route. And so here's a demo video. And what we're looking at, this is actually the example project in the ARCL repository. So we're searching for Boulder, and it was a kind of cool day. And so you can see the directions on the map, the route, and then you can see the directions going over my nice brown lawn. And they just head off towards Boulder. All right. So those were examples where we've actually had a lot of work done already. Supporting this application I've definitely seen a lot of support requests where people struggle spinning the app up from nowhere. So it occurred to me that, number one, I was about 20 minutes into my presentation and needed a little more time to discuss things. And secondly, this is actually a really important step. If you want to go from 0 to creating your own experience, it's important to understand all the steps. So I'm actually going to take what we look at next and start a wiki so that everybody can go through and create these projects. So number one, we start a project. And so this is the 360 AR navigation app. And I don't know if everybody's seen the email, but I started off with the idea of creating this demo app. And I literally went through and started creating it, taking the screenshots. And this app is in the App Store for you to download. And this is basically a walkthrough, and there's a branch that you can actually go see all of this code. I've extended it since then, so the develop branch is a little further along. So we create our project, and for those of you not familiar with ARKit, let's start with info.plist. NSCameraUsage Description. Anytime you're going to create an AR application, you need to go fill out the privacy information for why you need the camera. And it's kind of hard to read, but essentially what this says is we need to make use of your camera to provide you with this AR navigation experience. Secondly, since we're using the ARCL, this would be the CoreLocation side of things, we need to add a NS location when in use usage description privacy string. And I essentially gave the same exact description, but taking camera and swapping it for your location. As it turns out, Apple doesn't like this. I got a rejection, and I had to go and update this. So I'm sure we've all been through this. The description is pretty important to Apple, but also your mileage may vary whether or not they accept or reject it. All right, tooling. I'm a CocoaPods fan, for better or for worse. So I went and set up CocoaPods in a gem file, and I use a Ruby version manager, but that's out of scope for this talk. So next is to do a gem install, a bundler, and then do a bundle install, and so that gets you set up so you can run CocoaPods. And then next, we do a pod init, which creates a pod file for us. And next, we edit the pod file. And what we add, basically, is pod ARCL, and the current version is 1.2.1. And then we do a pod install. And that's it. We close our Xcode project, and then we go and open up the XC workspace that CocoaPods creates for us. Next, we open up the storyboard and we start building the interface. It's a pretty simple and basic application. It's a table view with our logo up top for 360 iDev. So we'll talk a little bit about building out the table. So first, these are the actions. In the application, we're going to show essentially those banner views where we have pins, and the pins are for the different places that we go for this conference. So first of all, right here at the Hyatt. And secondly, all of the eateries. So we've got Henry's, the food trucks, and then the Rhino Beer Garden. And the idea is that you can go outside and walk around and see what direction is it to each of these locations with pins. All right, so pretty basic table view handling. So the first thing is that logo up top. So if you click on the logo, it just launches Safari with a 360 iDev website. And now we wait. So we've got these actions, we've got a place stubbed out, we'll come back to this after. All right, first, we've got show location pins. So what we're going to do is build a view controller for that to handle it. So this is the show pins view controller. First are the imports, ARCL, CoreLocation, and UIKit. CoreLocation is important. We'll see in a moment, just because we're going to delegate and use some of those So the first thing we do is we go and we create a scene location view. Now, one limitation of ARCL is that it doesn't seem to not crash if you throw a scene location view in Interface Builder. So it seems like you want to go and do this programmatically. Should probably create an issue for that. All right, so next, we're going to go to view did load, and we're just going to do the basic stuff of adding a scene view, and we're not using auto layout. Yeah, you can all shame me if you'd like. And then we're going to go and add the pins, and we'll get to that in a moment. So next, view did layout subviews. Again, we're not using auto layout, so shame. We're just going to do the anti-pattern. All right, now here's where it gets really important. So view will appear. At this point, we want to call scene location view.run, and this basically tells ARCL and ultimately ARKit to fire up and to start doing its thing. And this is also important. When view will disappear, we want to pause the location view. So this is important for pausing resources, and this is very much an ARKit thing. All right, so we're going to look at add pins now. And so this is where we start entering the real work of ARCL. So again, this is the same paradigm we looked at before. Make sure we have a location, and make sure that the accuracy of that location is at least 15 meters. And so now what we're going to do is iterate over all the actions, and we're going to look for actions that are actually a location, because that first action is actually a pin location. It's not a location, it's an action, but the other ones reflect actual locations, like the Hyatt or a restaurant. And so we're kind of reusing that. Later, we'll also use those for navigating to the actual ARCL navigation. Navigation is kind of overloaded in this context. But the AR navigating through maps and the real world experience. All right, so the first thing we want to do is make sure we have an actual location on the pin, or in the action that we're going to show for the pin. And we want to make sure that we have an image, because we're going to show that image for the pin. And then we're going to create our location annotation node using those two things, like we saw earlier. And then we're just going to go and add this to the scene location view. Here's the assets. And I just grabbed essentially these images and threw them into bubbles in Sketch, and then exported them. And now we're going to show the pins. So back to the table view. So we're just checking to see if the index path row is not equal to 0. Then what we're going to do is go and grab this, if it is equal to 0. We're going to create this show pins view controller, push it onto the navigation stack, and at that point, ARCL takes over, and we get the pins view. All right, moving on. Now we're talking about navigation. So this is the cool part. So we create this navigate to view controller. And again, the important bits. Number 1, we need our imports. Number 2, we need a scene location view, and we've just got a computed property to get us the current location from the scene view. And this is the action. So we push that, or we set that action before we push this view into the navigation stack. And then we call this navigate on the did stat of this thing. So we'll see that in a moment. So again, view did load. Essentially, this is the same as the last view controller that we looked at. View did layout subviews, not using auto layout. View will appear. Again, I want to highlight scene location view.run. This is important. Otherwise, you end up with a black view, and you end up scratching your head thinking, why isn't this working? And then pause, to pause all of your AR activities when the view disappears. All right, here's the nitty-gritty. So this is navigate to address. So this takes an address which we got from the action. So this is going to be the physical address, and what we're going to do, like we saw earlier, is we're going to go and request the address, and we're going to create this search, and then we're going to search for a location, and then we're going to poorly handle the errors that come back, not telling the user anything, just silently fail. And then we're going to call navigate to, but this time it's an MK map item, not a string. So at this point, to review, we've taken an address and we've searched for it to get back an MK map item that we're then going to call navigate on. So now we're moving to the next navigate, and again, this is the one that takes the map item. So we create our request, set the source and destination from wherever we are to that map item. And then again, we're just picking the first route that we get back. And then we create our directions request. We call calculate, which is asynchronous, poorly handled any error condition, and then delegate to the main thread to show that actual route. So one more function to review. And so this is show. So it takes a routes collection. In reality, we only care about the first one. And so we make sure we have a location. Again, this is very repetitive, but make sure we have a location. Make sure it's at least 15 meters of accuracy. And then dispatch to the main thread, and we call show in half a second if that condition is not true. Otherwise, we call add routes, where we add the route to the scene, and at that point, ARCL takes over and it's going to begin rendering that AR experience. All right, so this is the last piece going back to that main view controller, the table view. So before we looked at if index path row is 0, showing the pins. So if it's any other row, it is a location like Henry's or the Hyatt. So what we're going to do is create this navigate to view controller, and then we're going to set the action from the current index path row. And then we're going to push that view controller onto the navigation stack, and the code we just reviewed a moment ago takes over, and we end up with the AR experience. So here's a quick demo. And you notice it's a little off, and it's kind of rotating a little bit. And we'll talk about that in a moment, but the one comment I will make is that it has to do with location accuracy. All right, so let's talk about some limitations. All right, first off, there's no simulator support for this stuff. If you've worked with ARKit before, then you're aware of that as well. But the idea is you need a physical device. And due to the core location and the fact that you need a physical device and it's AR, you need to go outside, for better or for worse. I see that as a benefit personally, but your mileage may vary. Occlusion. I don't know if you're familiar with occlusion, but the idea is that I want to render something behind, say, a human or behind that projector. The problem is that that is a current limitation of ARKit. It's going to render whatever you're rendering, it's going to show up in front of it, and we call that occlusion. In iOS 13 and ARKit 3, they've added what's called people occlusion, meaning that in your AR experience, it can detect people, and it actually can essentially green screen the person in front of or out of your AR experience if it's relevant. Memory consumption. So this is a big one. If you have too many nodes visible at one time, you can end up with some pretty nasty performance, sluggish behavior, so it's really important. In that demo that I showed where I was out hiking and skiing, I showed 5 at a time. If you can imagine a trail that has, say, 100 points versus 5 points versus 1,000 points, you could end up crashing just because you eat up too much memory. So that's something to be aware of. All right, location services quality. For those of you familiar with location services, you're probably perfectly aware of this. In my experience, about the best results you can expect are to be 6 meters of accuracy. In other words, you can expect to be, at best, 6 meters off from where you think you are in the horizontal plane. And by horizontal, I mean latitude and longitude. And so that equates to horizontal accuracy. And secondly, your heading, or what way are you looking? Where are you pointed? And specifically, what way are you pointed? That can be as much as 15 degrees off. So that also is a bit of a roadblock, or it can be. And as you saw in that demo a moment ago, we saw the directions kind of off kilter just a little bit and then sort of correcting. And so what you can end up with is this jarring effect where you see your objects jumping around or acting kind of funny. And that has to do with either location information getting better or worse. And then moving very fast. So the applications that this framework is really meant for is more for like walking. This isn't really meant for driving in your car. And the idea is because it's updating so quickly. And part of this may be the library as well. Like there's definitely opportunity for more tuning. Things like how frequently should the ARKit be moved around based on your location. All right, so let's talk about some pitfalls. So one of these you've seen me work around a number of times, which is adding nodes too early. For example, if you add nodes before the scene has your location, they just don't get added. They disappear. They never appear, and so you end up with a nice AR scene that's just your camera and nothing more. So that's something to be aware of. So creating a great AR experience, I think this is the biggest one, and this is one I still haven't figured out yet. This is one that I think takes a lot of experimentation, a lot of testing, and a lot of iteration. So that experience that I showed where I'm out hiking is really neat, but I think there's still a lot of room for improvement, and I think getting it right also to where it's really usable and it's really meaningful to users and adds value, I think is tricky. And so that's one that I'm still trying to figure out. All right. I guess I'm a nervous presenter who flies through slides ahead of time a little bit. This is good. So I've got resources. First, ARKit CoreLocation. This is the library itself. My fork, and I have a number of experimental branches. One for the states demo, a number of other things. There is a Slack group and GeoTrackKit. I guess to talk a little bit about that, GeoTrackKit actually has proven to be very valuable to me as a place for me to cross-pollinate between the two libraries. In GeoTrackKit, I have an example app where I've been able to walk outside my door, record a track like walking around my neighborhood, and then pause it, and then work on a branch where I have ARCL pulled in, and go and play around with that because now I have a bunch of points and I can actually start working with these. Versus, say, something like the projects that I work on for work where they're trails where I'm literally going to have to walk out, drive somewhere to a trail, let's say, and test it there. So that's been really good. The last link is the 360 IDEV AR navigation app, and that's the source code, not in the App Store. And that is more or less it. So questions, comments? Yeah.
You mentioned that you get about, at best, 6 meters of accuracy. You said at best. Does that mean that you mean from your actual location to 6 meters will be in that range at best? Or does it never get where you exactly are? I misunderstood.
Right. That's a great question. So I would say to exactly where you are. So if your GPS says you're at this specific lat long, at best, I mean, you get back the information. So when you get a point, you have a horizontal accuracy, and you can look at that. And in my typical experimentation, usually the best I see is about 6 meters of accuracy, which means I could be 6 meters in any direction, roughly. So it's kind of like you're here plus or minus 6 meters in any direction. And then there's also a vertical accuracy, and that corresponds to your elevation. I actually skipped over elevation a little bit. One other pitfall that I would add is that elevation is really important. A number of users, myself included, have created these experiences and done everything right, but never set the elevation, and you don't see anything. Here in Denver, we're at a mile high, and the default elevation is 0. Well, that point is way down below you, and these nodes are scaled based on distance to them. At least the 3D nodes are. Yeah, that's a really good question. Questions? Comments? Yeah?
Have you actually tried to suggest features to improve commentary regions by rotating the phone on X, Y, Z axis? Because this is how they're 6 degrees or 15 degrees off.
Sure.
Because their magnetometer regions they adjust with the offset. So to correct that offset, they can just rotate the phone multiple times on all of their axes, and then if you go to Google Maps or something, you see this kind of.
Right. Yeah, that's not something that's in the library right now. I think that would be a great addition. And on that note, there are 2 of us right now that are actively contributing, and every now and then we get some contributions. If anyone would like to play around and contribute, please do. Join the Slack community for the project. Feel free to play around, ask questions, submit PRs. I tend to spend a lot of time doing support. So it'd be awesome to have a bunch of people to jump on, and ideas like that are exactly what we need. Create an issue, add it to it, and let's play around. Let's get that stuff going. It would be awesome. That's a fantastic idea. All right, you're quiet. Very quiet. Thank you.